Good morning, everybody. Welcome to another Wednesday webinar, proudly sponsored by the Dairy Standard Agency. It's good to see you back, and we are so glad that you could join us. I'm Jacqueline Odendaal from the DSA, and with me is Jandri Klopper from Plaas Media, who will facilitate the question and answer session at the end of the presentation. You are absolutely welcome to write your questions in the question bar, or you can raise your hand during the Q&A session to ask your question directly to the presenter. Jandri will then allow you to speak, but please just make sure that your computer is then unmuted. Special thanks to Plaas Media for their marketing and technical support. We have an interesting topic today: hygienic design risk management in dairy processing. And we are really fortunate to have the expert, Piet Grobler, with us to share his knowledge and his expertise on this subject. Hygienic design risk management combines hygiene risk assessment and hygiene risk reduction. And with this webinar, we'll gain insight into the processes and procedures to follow during risk assessment. It gives me absolute great pleasure to introduce Piet Grobler, who is the chair of the European Hygienic Engineering and Design Group. He's also an authorized trainer, the head of hygiene and food at the OFT Group, and also the sales director of Centratech. So absolutely great to have you here, Piet, and I give over to you, and we are looking forward to your presentation.
Thank you so much, John. Jacqueline, I just want to make sure, that my camera is on.
Yes, everything is right.
Okay, all right. Thank you so much, and thank you for that introduction. As you mentioned, the topic of our discussion is about hygienic design risk management. We've been involved in the South African market now since 2019, and with hygienic design being with a focus on hygienic design and the importance thereof, I think it's really critical for establishment and food producers and even food equipment manufacturers to get first-hand knowledge of what it actually implies. What do when we talk about hygienic design risk management, what is it? And on the fortunate side is, and that's what I will share with you, is that there are a number of resources that is available to us to assist industry in getting to grips with this concept. Just from an agenda perspective, just introduce the EH, those people who might not know the EH organization, just give you some background in terms of EH. We'll talk about hygienic design versus food manufacturing. And what is interesting is you'll see the link between hygienic design and what we know of HACCP and those sort of systems that we've been dealing with for many years. How does hygienic design actually fit, and what are the differences pertaining to that? We look at hygienic design principles. The GFSI scope J1 and J2, we'll have a discussion around that scope that was introduced, as well as the FSSC 22,000 and their involvement and their support in terms of assisting the industry. And then we'll delve a bit deeper into the hygienic design risk management process per se, and our reference material there will be the guideline, EH guideline number 58, and we will go into detail, and you'll see how that can support you in terms of implementing the requirements, and then also just some case study in terms of what we've established or what we've done in South Africa, and the outcome on those case studies, specifically to dairy. Right, so the European Hygienic Engineering Design Group, it's a global non-profit consortium of food manufacturers, equipment manufacturers, industry itself, public health authorities, and other interested parties. And the vision of EH, and that is global, is to raise hygienic design awareness. We particularly see that in South Africa, where hygienic design is a concept that is not yet fully understood in totality, and also to guide industry and provide solutions, and that will be through the various guidelines that EH produces. And Global Network will run some numbers and just share with you what how many people are actually involved in this network, and a lot of them are subject matter experts pertaining to certain aspects of hygienic design, and we'll get a bit more feel in terms of what work they do. And the vision is really about becoming the leading source of hygienic design expertise. We as EH are of opinion that any company, any interested party that requires support or assistance can contact us directly, either locally or internationally at our head office. But yeah, for information regarding to hygienic design, and then it links very closely to what we're trying to do in terms of enhancing food safety in operations. Once we've gone through the presentation, and those people who've attended our training courses will vouch for the fact that there is a very strong link between hygienic design and the safety of the food that's being produced and supplied to consumers. And also, obviously, it will also impact quality. Just some of the activities, and these are global activities. It's not just in South Africa, but you can see there's 750 plus companies and institutes that are members of EH. And please, if you wish to become a member, you can go to the EH global website, and you can get guidance in terms of the process to follow to become a member of the association. Guidelines. So what EH does is they produce guidelines on specific topics, and they then put together different working groups. Currently, there's around 33 working groups currently working on guidelines, and there's more than 55 plus, I think it's closer to 60 published guidelines. And on these guidelines is that from a membership perspective, members have access to those guidelines, but they're also you can purchase them independently if you're not a member. So please go and have a look at those guidelines. Training from the guidelines, EH produces training material through the Training and Education Working Group, and we in South Africa also conduct the Advanced Hygienic Design training through the University of Pretoria as a facilitator or as an administrator based on the guidelines. And I'll share with you a bit more information later. On certification, EH also certifies equipment and or components, and they've developed cleaning methodology, specific cleaning that they perform at accredited laboratories, and So if you have any piece of equipment that that you would like to have certified by please reach out to me, and I will then connect you with the relevant people. The concept is you will submit your design, your drawings. Will, or the inspectors will view that, assess it, and then you can issue your equipment to the laboratories for testing and certification. And then obviously we're a global organization, and there's just an indication in terms of where we operate globally. Right, our product portfolio, and we'll touch on a number of these concepts during the presentation, but general principles of hygienic design, maintenance, seals, welding, all those type of concepts that is important when it comes to the principles of hygienic design. And as I said, we'll go into that in more detail. Then factory design, so it's not just the equipment design, it is the factory as well, air handling, refrigeration, those are all aspects that gets covered. Very important from a dairy perspective is the closed equipment for liquid processing. Again, various aspects that we will look at there in terms of seals, pumps, sensors, etc., and what impact that has on our quality of our product and also the safety of the product in essence. Closed equipment for dry particulate matter, especially when you look at powders, which has quite different requirements as to closed systems. Today we're going to focus on closed system. Open equipment, we'll talk later about definitions of what are closed processes, what are open processes, and how the risk pertaining to those different processes differ. Packaging, heat treatment, and then cleaning and validation. On the practical side, I will share with you some case study on the validation and cleaning, specific again relating to the dairy industry. Test methods, the certifications, as I said, certification gets done in the laboratories, approved laboratories, and there's this very specific test methodology that they follow. Again, if you would like to have a look at it, it's available on YouTube. You can just type in certification, and there are some videos that you can have a look at and see how it actually gets performed, the test. And then training material, as I've indicated, and education, very important, and something we are focusing a lot on in South Africa, collaborating with various partners along the process. Right, so that's just as an introductory of EH. When we talk about hygienic design risk management, and that is the topic for today, what resources are available? So EH has some documents that is downloadable free of charge from their website. So you'll see EH have written a white paper on the GFSI J1 and J2 scopes. J1 relating to equipment manufacturers, J2 relating to the equipment users, and within that white paper, the whole aspect of how do these different elements fit into the food safety management, into HACCP, and also into GMP. So there's very good guidelines in terms of that approach. Then EH have a number of other guidelines that can assist you. And there's a list of the guidelines, document 8 on the hygienic principles, which we're going to discuss now, some materials of construction. A very important thing is the integrating of hygienic entities. So what would happen is you've got a current system running, a current line, take a UHT line, and you're going to do some modifications, etc. Is how do we actually integrate what we've just, what we're going to implement, and what are the risks, and how do we mitigate those risks. The hygienic design principles of food factories is a very, very comprehensive document with a lot of detail that that can assist you. And then guideline 58, that's the one we're going to look at in a bit more detail, and that's about hygienic design risk management. I can encourage you, if you're in the process of looking at the risk management within your plant and within your facilities, that's a document, again, very comprehensive with some clear guidelines, templates that can support you in achieving or starting the process and driving it to completion. And then obviously there's some various other standards and guidelines from EU, ISO, etc., that you can have a look at. And on the FSSC 22000, they've issued a guidance document. I will share my detail later with you. If you don't have it, I'll share my detail with you, and it's a document that I can share what the requirement is when it comes to equipment management, and it really relates to purchase specifications and then risk-based change management. And once we've gone through the concepts, it'll be more clear. Right, so what is the difference? We talk about hygienic design, and we talk about food manufacturing. So when we look at the right-hand side on the HACCP GMP side, that is a concept we are very familiar with. We're looking at the process, we're looking at our product, we look at personal care, personal hygiene, cleaning, a whole host of aspects. And the end result is that we've identified risks, we've put in mitigating actions and activities, and what it really relates to at the end of the day is product quality and product safety. When it comes to machinery, from a hygienic design perspective, it relates to equipment components, installation, and we'll talk later about it. It's about installation qualification, process qualification, performance qualification, all aspects that we need to consider, including cleanability, and that relates to the quality of the equipment that we use to process, and that will then entail the risk assessment on the machinery itself. So what are the hygienic design principles? We'll talk later about 5 that is mentioned in the guideline 58. But in general, when we talk about hygienic design principles, is first of all, we need to understand our risk. Is what if I have a component that has direct food contact and it could cause harm to my product. And again, those risks relates specifically to the HACCP, the physical, chemical, microbiological type of risks, but there are also other risks, specific factors that we need to consider. Is my surface cleanable? Again, what influence cleanability? We talk about surfaces being smooth, and I'll talk a bit later about smoothness of equipment. We talk about it not being corroded, it not being impacted by our product, not being impacted by our cleaning chemicals. So a whole host of aspects that can influence or make our surface a lot more difficult to clean. Even relates back to our product. So if you think of a pasteurizer versus cleaning a milking line, it's very, very different. Are my materials suitable? So again, we'll talk about those definitions. If it's direct food contact, in other words, equipment comes into direct contact with the food, is it suitable, or is there going to be any negative effect on my product? Are my surfaces drainable? That's a very key, especially in liquid processing, where we've got pipes, tanks, valves, etc. So drainability becomes very important. Obviously, it can leave food residues it can cause problem in terms of our cleanability and the outcome of our cleaning programs. Is my equipment accessible for cleaning? We have the saying in EH, if you can't see it, you can't reach it, you can't clean it. And as such, it's very important that we have access to various areas of our equipment to ensure that it can get adequately and effectively cleaned. When we seal and material and we have to weld material, is it done properly? Is it done in compliance with, again, EH has a number of guidelines that can support you on this. Are there any dead legs or crevices? Again, can cause problems. Hollow bodies, corrosion, cross-contamination vectors, again, is how does our process flow? And we need to take all of those aspects into consideration to ensure that the contamination can come from equipment, people, processes, raw materials, etc. So the whole concept needs to be controlled. And then is my cleaning documented, inspected, and validated? Very important. Again, I'll touch on the aspect of validation. So we talk about accessibility. Yes, just a framework with a big question mark in terms of how can you have accessibility? What's the accessibility to clean below that frame? How often would it be done? Because of a lack of accessibility, it could be problematic. That's just in terms of framework. When we talk about closed processes, in our tanks, we have spray balls. There again, it's a surface or a gap tank. Again, how do you clean that? The spray ball will definitely not be effective to remove any soiling trapped in that area. And then also picture on the right hand side is where there were things added to the tank for whatever reason, and what it is creating dead legs that obviously compromises the cleaning outcome from a CIP perspective. Drainability, when we look at tanks, is how are our tanks designed? On the left-hand side, we have a tank with the outlet too high, and so the drainability becomes an issue. The blue area is your product, and then obviously the orange part is where there can be soil buildup because it's not drainable. The same thing with the figure on the tank on the right-hand side. Outlet is too far up into the tank, again creating areas that is not fully drainable, and you can get soil buildup and get cross-contamination because of that. We use a lot of stainless steel in the dairy industry. Just the indication on the types of stainless steel that we get austenitic stainless steel, ferritic, duplex. Again, depending on our product that we're manufacturing or processing, the chemicals that we use to clean, those are all aspects that need to be taken into account when we decide what type of stainless steel would be most suited. When we look at typically in dairies, you use 304 and 316 stainless steel. The big difference on the 316 stainless steel is you've got molybdenum that gives you extra protection against any corrosion that you might encounter. So again, we need to be very clear on, and we talk here about direct food contact. So it's important that we use the correct material. Then we talk about surface roughness, RA, and yes, just a graph and EH, based on the work that EH have done, we talk of surface roughness of 0.8 and lower. for direct food contact surfaces, like pipes, tanks, etc. And then within equipment, like a centrifugal pump, we can allow slightly higher surface roughness because you've got mechanical action within the pump itself during its operation that aids cleaning. So it's really about cleanability. Is my surface roughness too high? Then it becomes more difficult to clean, and it obviously gives a lot of challenges where it will require either longer cleaning times, higher concentration chemicals, higher temperatures, etc. But each one with its own negative impact as well. So ideally, when it comes to CIP specifically, you would look at your efficacy and your efficiency. In other words, you want to clean a piece of equipment as effective as possible and as cost effective as possible. Another important thing when you talk about liquid processing are pipe connections, and we see this in the industry, is what couplings do we actually use. So EH has a document, and it's downloadable free of charge. You can download it. Is what type of pipe connections is ideal to be used within your operation. Yes, just an example. On the left-hand side, we've got a DIN 11851 coupling. And remember, we were talking about the different problems we have in terms of hygienic design, and one of them are crevices. So what happens is, if you look at the coupling on the left-hand side, there's no metal-to-metal stop. So in other words, it creates a gap where soil can build up, and you can have problems. Similar on the clamp on the ISO 2852, there's undefined closure, again causing crevices. And what it actually also does, it forces the gasket into the product flow section, again creating areas where soil and micro buildup can take place. We've spoken about the 11851 coupling. When we look at the 11864, there you can see you've got centered sealing, controlled compression because you've got metal-to-metal stop. So again, we need to be sure that our couplings, and you can think within the dairy how many couplings are being used. Again, we need to, from a risk assessment perspective, need to evaluate and make sure that we mitigate all risks pertaining to the couplings themselves. We'll talk later a bit about the welding as well, and what impact that can have. Right. So when we do welding, and we want to make sure that we do not cause any crevices, we don't cause any areas where there's metal-to-metal contact. Again, we need to be clear in terms of what should be welded, how should our welding look like, and what is. So we talk about continuous welding, and there's whole other aspects. Again, there's a guideline relating specifically to welding, and I'll show you some pictures of some welds that we've seen in the industry. That is actually very interesting once you assess it with endoscopes or other methods. Sloping, again, you don't want 90-degree angles. It just provides an opportunity for soil and microorganisms to accumulate. So there's a guideline in terms of what slope should be, and obviously the benefit thereof is more easily to be cleaned, it's smooth, etc. Are all aspects that we need to consider. Here's a picture of the welding. So when you weld, this is specifically pipe welding. You don't want any misalignment. They do allow some toleration. You don't want lack of penetration, because again, those areas all cause crevices where soil can build up and cause problems in terms of your process, and also then contamination risks that we need to take into consideration. Another aspect when we talk about liquid processing is our seals that we use. Here's just a diagram explaining the different types of seals, from normal rubber seals, EPDM, most common used in industry. You can see there it's hot water resistant, can tolerate steam, ozone, UV, and others. And if you look at the temperature range, however, EPDM, as soon as it comes into contact with a oily product, so if you're processing a product that contains high oil content, it actually causes EPDM to become not suitable for use. And it's FKM, etc. Again, this is just an indication. So aspects relating to seal selection, when we talk about risk, is that we can have a discussion with our manufacturers and then just let them assist in terms of what's the best elastomer to use for which application. And again, I had a recent discussion. We exhibiting at Southforst this last 3 days. Today the last day, and it was interesting to hear people having product contamination problems, and it actually how they, through their investigation, found it to be from elastomers that haven't been properly maintained and properly replaced if required. Right. Other than the elastomer, type of elastomer, its design. If you want to seal something, there's just an example of an O-ring in a rectangular groove, obviously creating areas of where that's not properly sealed, where product, soil, and microorganisms can actually ingress and accumulate. We talk about areas where we have low flow zones. When you look at piping, for example, if it's not properly designed, what you will get is a flow, and areas where there's no flow. And we know that when it comes to CIP, we require mechanical action to support us in the cleaning process. So obviously, if there's low flow, that will not be adequate to remove soiling. And when you talk about the equipment itself, this is just a what's name, impeller from a centrifugal pump. That damage is due to cavitation, and so again, it's not just the equipment, the lines or the tanks itself, but it also relates to pumps and other components within our CIP that is critical and needs to be assessed, risk identified, and validations adequately done. Here's another example. We talk about drainability. This is a low pump. The one on the left-hand side is in question because of the fact that in that pump is not adequately drainable. So you get in that sump, you get accumulation of product and cleaning detergent. So it's never drainable. So better option is the low pump to the right, how it's installed, and how to prevent or to ensure that it's fully drainable. Another concept when we talk about CIP cleaning is dead legs. So it creates areas where you do not have adequate flow, and you can get buildup of soiling. I've done last year I did a talk the DSA on CIP specifically. So these are all areas that we need to assess as well. Tanks. Another concept is our spray balls. Which spray ball are we using? Once we've replaced or changed the design of the spray ball and put in new spray balls, we need to again validate and ensure that you get adequate flow rates, and there's a host of aspects that we need to consider when it comes to the spray balls itself then. Right, so these are all concepts when you talk about liquid processing that can have an impact on our quality. Again, it needs to form part of our risk assessment. So to come back to the guideline, here's just the aspect of the guideline. It's to support the suppliers in terms of the design, fabricating, and commissioning of equipment and buildings. It goes across both aspects, and as I mentioned, it then also touches on the points of the J1 and J2 requirements from the GFSI. So what do we need to, if we start unpacking guideline 58, what do we need to do? We need to consider the life cycle of the entity, and I will discuss the life cycles now. Very important is the user-supplier communication. So it's the risk management actually starts in the design phase already, and we'll go through the detail in terms of why that is important. We talk about proactive and then reactive in terms of managing risks, and you'll see the importance why the supplier user communication is so important. Then we talk about risk reduction pyramids. So once a risk has been identified, is that how do we reduce that risk? What measures do we need to take? We've identified a risk. What measures? And again, this guideline has some checklists that can support you in terms of that process in terms of hygienic design risk management. The scope really relates to equipment, legacy equipment, in other words, equipment that's in place, but also relates to custom designed food equipment, new generic equipment, also buildings. So the scope covers all aspects of equipment from the point where it's existing, where there's modifications. We need to understand the risk. We need to conduct our hygienic design risk management and follow due process. And then also, obviously, if we want to start installing new equipment or design new equipment in terms of our requirements. So what are our objectives of our hygienic design? There's three aspects that we need to consider. First of all, you want to prevent ingress. So you do not want any contaminants to actually find their way into, be it a piece of equipment, a crevice in a piece of equipment, or a bad design, area of bad design. So we don't want ingress of microorganisms, soil, product, etc. We want to prevent growth. So again, we need to adequately design so that we do not have, again, ingress of organisms that can grow, and then prevention of accumulation. So as soil actually accumulates, it becomes more and more difficult to remove. The risk becomes greater, and that is when people start, or companies need to start taking extra precaution because of accumulation of soil. We talk about biofilms, etc. So very important that we need to understand that and need to identify that and address it during the design phase, and not wait for it to actually become a problem. So the design principles, we earlier spoke about the 10 design principles. Yeah, the 5 that the guideline 58 takes into consideration. So we talk about the ability to drain. We've spoken about that. The ability to clean. What material of construction we need to use to ensure that we do not contaminate our product. We can clean adequately, and that we can manage risks. Ability to segregate, that's everything from process flow into aseptic filling, valve on aseptic filling, where you need to have a steam barrier, for example. And important, the ability to access. Again, as we said, if you can't access it, you can't clean it, or you can't reach it, you can't clean it. So the elements, here's just a breakdown of the elements in terms of components. We talk about the seals, pumps. We spoke about pipe couplings, the integration principles. This all relates to equipment. Is my equipment open equipment? How's the hygienic welding is important. Elastomers. These are all aspects that we've covered earlier. And then on the building design, we talk about the plant layout, look at airflow, look at the flow of product, look at the flow of waste. All of those things need to be taken into consideration during the design phase. The building envelope itself, cabinets, design cables. Those who've been on our advanced training course will understand the importance of cabling and other designs that's important, so that we do not or that we mitigate any risk pertaining to soil buildup and other problems that might occur. So how does the elements link to the hygienic design principles? So yes, and this is appendix from the guideline, where we talk, if you just look at the sealing, material compatibility. Again, you don't want material that can allow, it need to be resistant to microbial growth, rust proof, etc. So again, we need to take that into consideration. Is it cleanable? Do we need to clean it? How do we clean it? How often do we need to clean it? Ability to drain. It shouldn't allow for moisture accumulation. It needs to be segregated, right, from roof structure and other utilities. Again, the concept is clear from a hygienic design perspective in terms of getting access. It links close to the ability to access. How do we get access to inspect and make sure that those areas are clean and does not pose any risk of contamination. Right, we talk about the criteria. So what is hygienic principle material compatibility? What is the criteria that we refer to? And this is also from the guideline, is materials, whether it's in direct or indirect contact, should be compatible with our product. So things like metal, rubber, plastic, organoleptic, those are all risk in terms of food safety and also from quality, from a quality perspective that we need to consider. The ability to segregate their cleaning agents, lubrication, allergens, these are all areas or hazards that need to be considered during our design phase. Ability to clean, obviously, the cleaning agents need to be considered. That could be a risk if you use incorrect cleaning agents. It can actually cause harm to equipment, harm to your product. So again, need to be considered. From a microbiological perspective, can we adequately disinfect? Are there areas where we have limited access or limited flow when we talk about CIP, dead leg specifically? Those are all aspects that we need to to consider, and these are typical hazards. Accessibility, and then also a criteria around ability to drain. So is my equipment, is it fully drainable? Do I need to do some modifications, etc.? So we need to keep that in mind. So we were talking about the life cycle phases, and you'll see it is from the point of construction at the supplier, where it goes to the food manufacturing site, into operation, and all those phases. So the risk management or study, or your risk study, should involve each one of these phases within your total hygienic design risk management program. So where it's followed, you've got a scope and a context. So what will be assessed, intended use, etc. So what you'll take then into consideration: the raw materials, the ingredients, what process are going to be followed, what equipment we're going to use, and what stage in the life cycle. We were just talking about the life cycle, and that cycle starts even at the equipment manufacturer, prior to delivering it to plant, before installation, before commissioning. So scope and context and criteria critical. Then we talk about our hygiene risk assessment. Now we need to identify our risks pertaining to food safety hazards. It's in essence a two-step process. And what are the contamination mechanisms? And we'll discuss that a bit later. Hygiene risk analysis and evaluation. Again, we need to understand what is the impact and what is the likelihood. And based on that, we can then classify the risk in terms of high, medium, or low risk, and implement the necessary mitigating activities. That's just an example of our hygiene risk identification. We talk about cleaning. We are worried about our contaminant being a biological contamination, and the mechanism is the accumulation. So what is the hygiene? You describe the risk, and if, for example, water remaining in a pump, so the pump's not fully drainable, what's the likelihood of it happening, what is the impact, and then the risk level. Next one is the risk reduction. So what measures do we put in place to reduce the risks that we've identified? And there's some principles. I'll just explain this, will explain better. So if you look at the triangle, is that hygiene risk reduction, if we can eliminate it during the design phase, it's all about being proactive. Looking at hygienic design principles, applying those principles, and as I say, during the design phase, ensure compliance, then it makes it a lot easier, because following on from that, if you start using engineering controls, SOPs, works instructions, and IFU, that's information for use, then obviously it becomes more difficult. So then it becomes reactive, and it is less sufficient and reliable. So here's the outcome of such a risk assessment. And this is an example from the guideline. You will see that we talk about it's about a new pump. It's cleanable in place, and it's EH certified that we want to replace. The context is defined. Where are we in terms of the life cycle? The criteria, what does it need to comply with? The scope, we look at our product, and we look at our operational conditions. And then based on this, we then done our hygiene risk identification. Again, we look at what is the physical life cycle, what is our contaminant, what's our mechanism, and what is the risk, and the level of risk, and then also the hygienic risk management report is how are we going to reduce that risk, what are we going to implement, and then the outcome gives you a whole hygienic design risk management profile pertaining to the specific entity. Okay, so the model is systematic. It considers all life cycle. We spoke about that. We spoke about the risk reduction pyramid, identification, and other detail. Just some practical application when we talk about a validation that forms part of the whole hygienic design risk management process. And this is an example from a validation we've done, and I've been personally involved in South Africa, where we looked at the design qualification. Scope was about CIP, looking at the processes. So we looked at design qualification, that involves all the equipment, spray balls, flow rates, etc. We looked at the installation qualification. There you can see is in terms of installation, what velocity do we need, what's the pipe diameters, etc. And then from an operational qualification perspective is during operation, what are we observe, what do we observe, and then the performance qualification is monitoring during performance. How is it being measured, and evaluating all aspects of it. So it's from design qualification, and you'll see within the guideline 58, it makes reference to all aspects of these qualifications. Another one, and this is real data where we send endoscope into product process lines, and you can see the corrosion on the welds, etc. Obviously, that's creating problems to us, and the design principles that's being used in the process when doing this type of evaluation. Another important aspect from these guidelines and from applying these principles, again, this is a practical example where I was personally involved in, is that how we, on the CIP specific, and then we talk, this is for dairy and it's very specific, is by applying these principles and the concepts that's defined within these principles is when we talk about CIP efficiency, and we're talking about cost, is what a positive impact it can have on even the CIP efficiency costs during operation. There you can see very positive. So these are these are concepts that can be practically applied, and then can also be to the benefit, obviously from cost, wastage, etc. Just quickly on the training, as mentioned, we do the advanced hygienic design course training, and we go through all these aspects from hazards right through to welding, chemical treatment of stainless steel and others. We have our upcoming training in Cape Town, 17 to 19 November. So if you're interested, there's a link that you can use and to register. Again, we go into much detail. What happens is it's a 3-day course. We write an exam. If you pass the exam, there's a certificate being issued by EH Global, and then also from the University of Pretoria. In addition, what we've done in terms of continuous improvement and getting getting everyone familiar with the concept of hygienic design. We've implemented hygienic design modules into the curriculum of final year students at food science students in one of their training courses. So we started this year with the final year students. So from next year, students going into industry will have a good understanding of in terms of what hygienic design is and what is required. Also important, it's linked to CPD points, so Engineering Council of South Africa, so you can get CPD points. Yes, our final slide, in terms of our contact detail, please, if you need any information or you have any questions, please contact either myself or Anne is our secretary for the regional section, and we will gladly assist you. So Jacqueline, it's over to you.
Okay, if anybody has questions, you can leave it in the chat or you can raise your hand and I will unmute you.
Yeah, I see one hand.
Ivan? Yes, Ivan, you can ask your question. Remember to unmute yourself.
Hi, Pierre. Thank you for the presentation and the information. I've got a question just on one slide. Just want to go up a bit. It was on the one where you looked at the design risk management, the approach. And
Yes.
there was a table that we established the off-scope context and criteria. So the
Right.
hygiene risk analysis and evaluation, there's a ME. Is that a medium risk? What does ME
Yes,
stand
yeah,
for?
the ME
Okay.
was the medium risk. So that likelihood multiplied by the probability, and
Okay.
so that's medium, yeah.
So maybe low, high, or medium?
That's
Low,
right,
medium.
yeah.
Okay.
So what it does, once you've identified, obviously, once you start implementing mitigating activities, is start with the high risk sections, and then work towards the low risk sections.
Okay. Thank
But
you.
bearing in mind, it could also entail, some of these changes could entail capex, etc. So again, you need to manage the whole process in terms of risk mitigation.
Thank you.
Okay.
Does anybody else have questions? Natasha, you can unmute yourself and ask your question.
Hi. So just two questions. You showed just a copy of the HDRM Excel template. Where can we find a copy of that? Is it available on the EHEDG website? And are we able to get a copy of the presentation, the brief presentation you shared today?
Yeah, you can, and then on the guideline itself, as members, if again, membership, remember, is global. So if you're from one of the global companies that's members, Nestle, Unilever, others, you have access to those guidelines, because all those checklists are within that guideline. It forms part of the guideline pack. Alternatively, you can actually you can become a member and also have access to the guidelines, or you can procure them individually. I think the cost is around about €100 for the guideline 58 with all its checklists.
Okay. I think Coca-Cola is a member, if I'm not mistaken, or not. Yeah. Okay. All right. We'll go through it. Thank you so much.
Okay.
Are there any other questions? Salwana, you can unmute yourself.
Okay, hello. Thank you. Can you hear me?
Yes,
Yes.
can you hear you?
Okay, my question is about after commissioning, say we install a new equipment, at what point are we supposed to determine all the checklist for hygiene design? Is it upon purchasing the equipment, during installation, or after installation to do the checklist and take it to say, no, this machine is cleanable, is drainable, the type of material is suitable, and it's not going to give us any dead legs and.
Yes.
So, and also the last part, I was just asking if you have a copy of saying authority to operate or a checklist to say after installation or changes in the equipment we can use to take before handing over the equipment to the plant or to production, that now they have the green light to go use the equipment.
Yes. Okay. You're highlighting important factors. First of all, and I didn't mention it, but during the hygiene risk assessment, you actually have a multifunctional team to do that assessment. Okay, so you'll have from engineering, quality, etc. It's like an ASAP study. You'll have everyone available. Now, remember we spoke about the life cycle within the process. So each one of those, so the checklist will start and it'll give you guidance within it. So from the design right through to installation and validation, it will give you guidance around all of this.
Okay.
Does anybody else have a question? It does not look like there's more questions.
Okay. Oh, thank you so much, Piet, for a insightful, excellent presentation. You've really added value this morning, and we greatly appreciate you. You can see the applause of hands. So thank you so much. I just want to mention that this presentation was recorded, so you'll find the recording on our website in a few days' time. And our website is www.dairystandard.co.za. And then our next webinar will be on the 17th of September, when Tabang Rampa from the DSA will unravel Regulation 1510, and she will also shed some light on the revision of this regulation. So please make sure that you register and that you don't miss out on this webinar. And then we'll keep you posted on the social media, and that's all that we have to say today. I just want to say have a wonderful afternoon. Until next time, be well.